Hi, everyone. My name is Mike Gualtieri, Principal Analyst at Forrester. I'm from Boston. And my coverage area is big data and advanced analytics. And I want to talk to you today about what I'm seeing in machine learning and really applied advanced analytics. Okay, so I'm not going to talk about algorithm development, but rather how those applied. And I think to set the stage, it's important to sort of understand what some of the business priorities are and set this up of why enterprises are really excited about advanced analytics and machine learning in general. We surveyed a bunch. Okay. I brought my own clicker, actually. I was hoping that it would work. So if you ask business people, what is the top priority of their business, it's clearly customer experience. So you can see some other likely suspects there, like reduced cost, but really the focus right now is on that customer experience. And the reason's obvious, because they're the ones who pay the bills, ultimately. You want to get new customers, you want to retain existing customers. And really the focus is more about individualized experiences. Way back when, you used to walk into the corner store, they pulled down from the shelf, they knew what you needed before you even come, they knew you by the first name, it was all about personalization. We moved to more mass relationships with mass production and industrialization where people didn't have as much choice. And then we tried very hard in the mid-90s to try to use CRM systems, customer relationship management, to have more demographic relationships. But still, that was more about segmentation. What's exciting today about big data and advanced analytics is we have more data, and we can create those individualized customer experiences again. I call those hyper-personal real-time relationships because they all have to happen in context. And at Forrester, we call this overarching business trend, we call it the age of the customer. I just call it celebrity because I think that nets it out to what it means. And in today's digitally connected world, everyone wants to be a celebrity, okay? And they expect the companies they do business with to treat them like a celebrity. So imagine George Clooney, imagine you walk into a restaurant. Do they have a cheesecake factory here? It's a US chain. Imagine you walk into any restaurant, what menu are they going to give you? They're going to give you the same menu as everyone else. But if George Clooney was going to walk in there, they would be preparing a special menu. They know that he loves prosciutto, so they're going to put that on the menu, okay? George Clooney might have a wearable, and it might have an API to the menu system, and it knows that he went for a 3-mile jog, so they're going to put the Kahlua cheesecake on the menu as well. The point is, we know an awful lot about celebrities, and now companies want to know an awful lot about you to treat you like a celebrity. And so I call these celebrity digital experiences, and that's what we have to use advanced analytics to create. We have to learn the individual customer characteristics and behaviors, detect those needs in real time, and then create applications that can adapt to serve those. All right, the whole internet is pretty much about that, right? It's going towards that. Enterprises need to create applications this way as well. So I'm going to give you a quiz to see how good you are at data science or answering these questions that I have for you. So we've got a male. He's 35 years old. He's single. He resides in New York, and he makes $100,000 per year. Bank accidentally transferred $5,000 into account. What do you think he would do? Would he give the money back or take the money and run? And I am looking for answers here. So anyone? Take the money and run? Sir, why?
New York.
Okay. He says he's going to take the money and run because it's New York. Does anyone think he'll give it back? Sir, why? Why will he give it back? So you think he'll get caught? Anyone else? Yes?
If he's smart, he'll take the money and run because
He
he hasn't done anything wrong.
hasn't done anything wrong? He'd take the money and run. Okay. So humans are beautiful because we have brains that fill in information in order to make a decision. The reality here is that you came up with guesses, but you don't really have enough information to know exactly what this person would do, right? So I'm going to give you a little more information, and then I want you to tell me, okay, because we're going to talk about predictive analytics in a bit, and that's all about probabilities. I want you to give me an answer and a probability. Okay, you ready for this new information? Okay, this is George Costanza from a character on Seinfeld. Maybe you don't know that show over here as much. But if you knew this character, and I think some people do, they would know absolutely he would take the money and run. Okay? Everyone who knows this character in Seinfeld, 100% probability. And this is how well we have to understand our customers if we're going to be able to predict what they want, what they need. And of course, we can't do that without analytics. And there's 4 types of analytics that I categorize that every enterprise needs. There's descriptive analytics, and that's where most firms have invested. This is traditional BI. This is historical analytics. And then there's these categories of advanced analytics that most firms need to invest in. They spend collectively billions of dollars on the descriptive, but not on the predictive, streaming analytics, and prescriptive analytics. And of course, there's analytical categories under all of these, but these are the 4 main that they need to create those type of celebrity experiences. And another data point here, you can see between 2014 and 2015, these different types of analytics, we asked a bunch of companies, 1,800, yeah, we asked about, more than 1,000 of our survey respondents. And you can see reporting, that's pretty much stable. I'd like to know which companies aren't doing reporting, that's pretty cool. But look at predictive between 2014 and 2015. There's a huge increase. Look at streaming. Look at some of those other forms of analytics, right? So between 2014 and 2015 alone, there's a lot of companies reporting doing a lot more. It doesn't mean they're doing everything. Now, this is actually good news, okay? Well, for the people who are already starting to do something, that's great. But for the companies that haven't, this is an inflection point. It's not too late, right? So if your competitors are doing it, maybe half of them are, but the other half aren't. So this is you can get more competitive, but it's not too late. So to do analytics, we need data, and people ask me all the time, well, what industries are doing this? They all are, because they all have more data, and they have it from all of these emerging sources, but they also have lots of data in their portfolio that they're not analyzing, their portfolio of applications that they're not analyzing. We surveyed them again, and they said, how much data are you analyzing that you have? And they said about 12% of it, right? So there's still a lot of opportunity to analyze data. And they have plenty of it. We also asked them to estimate how much data they have. And you can see here they have, I mean, these are pretty big buckets, right? So in that greater than 500 terabytes, there are many companies that have petabytes, but you can see the ranges there. And they also report that they have about even data from internal sources and external sources. And one of the things that I always think about when I think about data is that it's always born fast. We don't think of it that way, right? We think of it sitting in a database or sitting in Hadoop. It's a remnant of something that happened, but when it happened in an instant, okay? It happened because someone clicked. It happened because a transaction took place in a transactional system. It's data in a sensor. Data is always born fast, but analytics is usually done much, much later. And if we're looking to create these real-time experiences, that's too late, okay? So the question is, why wait? Why should we wait to analyze that data? Why don't we analyze it right now? And I call these insights perishable insights. You get it, right? There's some insights that are perishable, meaning if you don't act on them now, the information is no longer valuable. And how much analytics analyzes these perishable insights? Not many, maybe algorithmic trading on Wall Street. There's been a lot of use cases here that are all about perishable insights, but most companies wait to analyze their data. And perishable insights is a huge opportunity for companies. Sorry, these slides. Couple of examples of perishable insights: fraud, right? You don't want to know tomorrow they're fraud, you want to know right in a second. In fact, credit card companies, there's one credit card company, it takes 15 minutes to detect fraud. wouldn't it be nice to detect it right away? There's a lot of financial information services firms that are doing massive machine learning projects on social media data and other market data to determine what equities they may trade, right? And that's certainly a perishable insight. Once that information gets out, there's no longer the opportunity. In the world of IoT and wearables just aren't for fitness. There's one company here that creates a wearable for a baby. It's like a baby monitor, but it knows the baby's temperature, it knows the position, is the baby lying on its stomach or its back. Certainly if there's something wrong, that could be a perishable insight. The auto manufacturers, sensors in the cars, about 250 sensors in a car. I don't know, Tesla probably has 1 million sensors. And there's one company that's working on sensing the wheel slippage and then transmitting that to the traffic behind the car to warn them that there might be slippery conditions. Location analytics, okay? Many people have a digital phone. We know location analytics. How do you make them an offer right at that opportune moment based upon their other desires? So all these are examples of perishable insights. And one which, I think this is a Pandora screenshot, but I think Spotify actually ended up implementing this, is that they noticed from their analytics that most people were starting to listen on their mobile device. And they're saying, well, what can we do? What sort of information do we have? Oh, well, we have a GPS. Oh, we have the accelerometer. Oh, the accelerometer. What could we do with that data? Well, imagine someone's jogging. They can detect the jog, they can detect the tempo of their jog, and then they can stream music that matches that tempo, because runners listen to music that matches their tempo. So if you start to think of all the opportunities of capturing these perishable insights, there's a lot of them, okay? But you need analytics to do it. So we are urging enterprises to build all of these analytics, but think about it not just from a reporting standpoint, but think about it, how can I use these analytics in my apps? How do analytics become part of those applications? And so I just wanted to quickly take a look at these forms of analytics and show how machine learning fits in. First one is predictive analytics. And we published a wave on April 1st, 2015, so a little bit earlier this year. And Forrester publishes thousands of reports per year and almost 1,000 per quarter. And when this was published, it was the second most read report at Forrester. And you can see what it's flanked by, customer experience, right? So there's a lot of interest in customer experience. There's a tremendous interest in predictive analytics. And we define predictive analytics as tools, technologies that use data and algorithms to find models that predict with a probability an outcome, right? And the way this is done, well, let me just level set on the predictive models. Predictive models are about probabilities. So a lot of the enterprises I talk to, and you guys know this, but a lot of the enterprises I talk to, they turn away from predictive because they think it's impossible to predict. And of course it is, but if you go to Las Vegas and the casino, small probabilities, in their favor, of course, let them build all those big buildings and treat people in Vegas like a celebrity. And the other thing is accurate predict, but then people go the other way. They think you can create a predictive model for everything. You can't, right? They may not exist for every question. Economists are terrible. Politicians are terrible. There's a lot of terrible people out there. And also for the statisticians, predictive models are probably not causative, right? Especially when using machine learning. And this is just my disclaimer slide, because I'm going to gloss over a lot of things in this presentation. I want you to make sure that you know that I understand this and that you understand it. Here's a correlation, a model that correlates the divorce rate in the state of Maine, in the United States, directly with the per capita consumption of margarine, okay? So that's probably correlative. It's probably not causative, right? So predictive models have their limits, but humans are pretty predictable, and so that's where a lot of the use cases stand. And data scientists use a combination of statistical and machine learning algorithms to find those patterns, and we could argue about what's a machine learning algorithm versus what's a statistical algorithm, but we're not going to do that. I'm just going to group them together. And big data is why we're talking about machine learning. If any of you take an intro class in machine learning, you certainly don't do it with a big data set. They have a tiny data set that you create a predictive model. You don't need big data, but it certainly helps in a lot of the ones we're going to talk about. Now, many people ask me, well, how do you hire a data scientist? And that's, a lot of people are putting data scientists on my resume. I give them a little shortcut. First interview question, what's your favorite algorithm? Okay, if they say Cognos or business objects or Tableau, well, those aren't algorithms. But that's a good screening question, okay? And they may not have a favorite, or they may say it depends upon the use case, but then the conversation can continue. Otherwise, you can show them the door. This is the results of that wave where we evaluated 13 of the tools, and you can see sort of the results there. I'm not going to go through these, but a couple of those are open source. Nime is a Swiss-based company. RapidMiner, originally out of Germany, now headquartered in Boston, is also open source. So the other form of analytics is streaming analytics. And streaming analytics is what you need to detect and act on those perishable insights, those insights that happen in a window of time. And streaming analytics is not just ingestion. It's not just ingesting data and putting it somewhere else. It's actually doing analytics on there. And it will filter, aggregate. In many ways, it's doing ETL on the fly, but it's also doing analytics in stream. So when we say real time, we mean business time. So in algorithmic trading, it could be milliseconds or less. In location analytics, someone moving around, it could be a minute or a few seconds. So we don't have to get caught up in real time, because real time means different things to different business. So I just call it business time. And the other thing about applications and streaming data is most applications are they lack information. They have input from a user. Increasingly, though, now we have sensors, okay? And now we have IoT devices, home monitoring, and as the ecosystem starts to evolve, they start to work together. So now that we have more contextual data sources, now we can start to create those customer experiences, understand the context, and understand what they need in that context because we have more IoT information. Thinking in streams is very different, though, from batch analytics. There's really two sides of streaming. There's the continuous ETL, and that's where you're ingesting, you're filtering, right? There might be a lot of noise in the data, so you're just going to pick out what you want. You might have to transform it. You certainly will have to enrich it, probably. So if you're getting like a lat long, what does the place represent? If you're getting customer ID, what are the details about that customer? Because you may need to use that. It's almost like streaming feature creation in a way. And then the other side is the analytical side. So if you're looking at a streaming platform that's only on that continuous ETL side, that's a streaming platform, but it's not a streaming analytics platform. Continuous analytics will do correlations of multiple streams coming in. It will do location, motion type detection for geofencing. Time windows are critical. If you can't establish a time window, it's not streaming analytics, okay? And then temporal pattern detection is like if event A occurs and then B occurs, excuse me, within 5 seconds, that's a pattern detection, right? And streaming also has to output to the application to execute actions on what it detects. So let's look at a quick example here. Imagine we established a online retailer to sell motorcycle accessories, and we want to sell more of those helmets, and we want to optimize profits, of course, right? So there's two analytics we could use there in the streaming model. The first one is temporal pattern detection. When has this user viewed at least 3 motorcycle safety products, including 1 helmet? Okay, and has done that within a 30-second time window. Okay, now think about how you would code that if you're a developer. Okay, within the 30-second time when it's the key. And if the user did do that, then display the most profitable ones because they're specifically shopping for that. And then there's a second analytic, which is a time window. What is the real-time daily sales total? In that case, the time window is the entire day. Okay, and that's the real-time sales total. It's not the sales total from yesterday or the historical one or the average over a period of time. It's the one today. And if that sale is trending lower, lower the price, we could raise the price under a different condition as well. So these are analytics that capture those perishable insights and can take action on them. So if you look at how you might do that with a SQL statement, you can't do it with a regular SQL statement. That's why streaming analytics exists. And you could do it in programming, but that would be very complicated because there's statefulness to streaming analytics, especially if A comes in, you have to wait. Okay, I've got an A, now I've got to wait 30 seconds to see if a B doesn't. If it doesn't come in, I've got to dump that. Meanwhile, there's a million other events coming in. So streaming analytics is a very specific technology designed to accommodate this. There's many streaming analytics solutions out there now. We did a wave on this about 2 years ago. We had 7 vendors, and we've identified a number of vendors now, and you can see a number of them up there. Some of them come from a CEP, a complex event processing legacy, but all of these can have those capabilities that I just talked about. Now, the prescriptive side is what we actually do. How do we act once we detect that perishable insight? And how do we act in real time? Okay, so once we've detected the situation, what do we do about it? So prescriptive analytics is a little more complicated than the others because it combines approaches. It uses a combination of approaches. It can use plain old-fashioned business rules engine, right, to encapsulate human policies or human insights, because sometimes there isn't a predictive model for it, or sometimes laws. Like you might have an action that says, oh, we could sell more rum if we sell it to 16-year-olds, but there's a business rule that says, no, you can't do that, right? It also includes other predictive models, and it could also include, and it often includes constraint-based optimization, numerical optimization. The Obama campaign in 2012 famously used predictive and prescriptive, right? They had a predictive model that predicted who a swing voter was. Now the question is, and this is the heart of prescriptive, now what do you do to influence that person? What is the prescription to influence them? Some people, you knock on their door. Other people would be totally turned off by that. What do you say when you knock on the door? Do you say education? Do you call on the phone? Do you do an email? So there's many different actions. It's almost like a second model that you need to prescribe. What do I do now? So that's what prescriptive is. And prescriptive has to support both analytical, data-driven, and it has to support human decision makers. And that's why there's a combination of techniques required pragmatically in prescriptive analytics. And sometimes, most applications need a combination of all 3 of these approaches, especially marketing use cases. Now, the problem with predictive, streaming, prescriptive, and even descriptive for that matter, is that most companies struggle to get those insights at all. Nevertheless, notwithstanding, to even act on those as well. And when we ask them what those technical challenges are, this is the top rank list, no surprise to you: integrating multiple sources, large volumes of data, difficulty in creating models, too many formats, accessing it from multiple sources. Really, it really comes down to integrating this data and working with it. And that's one of the reasons why Hadoop and Spark has become so prominent and so interesting, because it can do a lot of this economically. And the way, I know we talked on the panel a little bit about Hadoop and Spark, but I'll just net it out for you. The way to think about it, I think, is Hadoop is designed for volume. It's designed for storing and processing volume, whereas Spark is designed for speed, for the speed processing, sharing the file system or loading the RDDs from Hadoop and then processing it in memory, although it can spill to disk. So these 2 platforms have had a huge impact on companies' ability to even think about doing this sort of advanced analytics. And so we call it Hadooponomics. And I'll tell you a quick story. A large telecom in the US, they've been doing churn modeling. Churn modeling is when you predict when a customer is going to leave so you can take some marketing action to keep them. And they weren't using information from the set-top boxes. These are the cable, the cable TV boxes. And so the data scientists said, well, I think we could get a better churn model if we use that data. I'm not sure, right? They're not sure until you do it. Well, it was about 200 terabytes of data. And I don't know if you know what a cost per terabyte is in a conventional data warehouse, but it can be anywhere from $25,000 per terabyte to $100,000 per terabyte, depending upon the configuration and the concurrency. Equivalent Hadoop system can be in the $2,000 to $3,500 range per terabyte. So what they did is instead they moved all of the data to Hadoop. They did this analysis. Okay, so can you imagine them going and saying, I need a couple $1 million to see if maybe this data will improve the churn model? No. So Hadoop and Spark together make that sort of experimentation cost-effective from a platform standpoint. And that's why it's so popular. Now, there's a term out there in the industry as well called the Lambda architecture. And the Lambda architecture, it's sort of an evolving architecture, but it brings these analytics together. It says, look, there's batch analytics with descriptive and predictive modeling, and then there's streaming and prescriptive analytics that act in real time. Right? So there's an architecture that brings those two together. They should no longer be separated where you're doing some batch processing here and you're doing your real time here, and there's a big gap between the two. The Lambda architecture puts those forms of analytics together. Now, the heart of what we're talking about here, though, is the predictive models and the machine learning algorithms that are used to build or find those models. And I think what the future of machine learning is to build predictive models is something I call MMLA, okay? And that stands for Massive Machine Learning Automation. And what MMLA is excuse me, is it's automating the data science process. If you look at the data science process, it has not changed for 20 years. You take one of those tools that I showed you on the wave, and you connect your data sources, you prepare your data, you create features, you run an algorithm, you evaluate it, it doesn't work, you try another algorithm, it doesn't work, you try that algorithm again, but you change the parameters on it, it doesn't work, then you try another algorithm, I'm getting some signal, but not enough, then you go back to the data set, maybe I'm missing some features, some variables in that data set, and it's a very iterative process. Okay? And the tools, no matter what the tool vendors say, that process hasn't changed. Maybe it looks better, maybe you can click and drag and drop a little bit better, but that process has remained the same. What massive machine learning automation does is it automates those processes. So it's tools and technologies that let data science configure massive runs, massive batch processes, if you will, and it can be done economically because we have platforms like Hadoop and Spark. And I'm going to go through what MMLA looks like. So, there's 7 characteristics of massive ML automation. The first one is data scientists configure the runs that they want to do instead of iterating themselves through every process. Okay? Instead of using the tool and then running it on the desktop or even running it and then seeing the results and then tweaking and then tweaking. Instead, they configure for a variable of to run many different algorithms. And you might be saying, well, running every possible algorithm is crazy. But maybe it's not. Maybe it doesn't matter because the processing is so cheap and the capacity is there. Now, the other thing is it has to scale to handle any amount of data. And it will do that by virtue of being on a distributed platform. It also has to have semi-auto feature creation, creating variables in that data set. And I call it semi-auto because there's some domain knowledge that's often needed to create the relevant features that will give you the signal. I'll talk about that in a second. But it has to have it has to have data prep automation and assistance. There's many vendors out there who are actually creating just data prep tools just to do that, just as like a separate tool, not even for, not specifically for machine learning. And then you have to run all the relevant algorithms in ensembles. So I say relevant algorithms because for certain problem types, it doesn't make sense to run every algorithm in your toolbox. There's certain algorithms that lend themselves well to certain types of problems. But it will just run them all. You'll configure and you'll run. Even if you're wasted some of those runs, you don't care. You cared before because you were limited by your compute capacity. You didn't want wasted runs. You didn't want to run it on all the data because you couldn't do it. It didn't even enter your mind. But massive machine learning automation will let you do that on these new platforms. And then once it runs all that, it will auto-evaluate and then rank all of these models. So you might run and create 1,000 models for one problem, and it will rank the ones that evaluate the best at the top. And by the way, part of that configuration could be, one of the choices you have to make as a data scientist is, do I do a 70-30? Do I do an 80-20? Why not just say, do every combination between 60 and 100, right? And then vary the training set and the test set. Why not just do that? You're saying that's crazy. No, it's not. We've got the computing horsepower to do it. Now, massive machine learning automation systems will need some domain-specific data and algorithm hinting. As I alluded to before, it's really not, there's hundreds of potential algorithms and combinations, and certain problems lend themselves well to certain sets. So there'll be certain groups. So part of that data scientist configuration will say, I am doing behavior analytics. I am trying to predict fraud. So there'll be little hinting packages that the data scientist will say, use this group. And of course, they can configure that package as well. And then finally, it will auto-test and auto-monitor these models in production. So auto-testing might be an A/B test, might be a champion-challenger type of test on the model, and it will monitor these models while they're in production. And many of the systems already do that. They have automated modeling, but MMLAs will need that as well. So using massive machine learning automation, it can find and refine more models faster. Bottom line, because it's automating or semi-automating that process that data scientists just slog through. Can you imagine writing an R program and then tweaking it and then tweaking it and tweaking it, or using any of those tools and tweaking it, even if it's a graphical interface? This is a configuration and it just runs. Now, these platforms have emerged. Okay, the Googles, the Amazons, they build massive machine learning automation platforms for their own use. And just like a lot of the internet giant technology, it inspires solutions for the enterprise. And here's just a couple of products that represent massive machine learning automation. One is called Skytree. That came out of academic research. Actually, I think it's Stanford, Georgia Tech. That does exactly. I just described exactly that product. And same with SAS Factory Miner. SAS Factory Miner came out a few months ago, I think earlier this year. And SAS Factory Miner, I've explained exactly what that product does as well. So there's products now that are emerging to do this. So enterprises, if you're not looking at this approach, it can have a lot of benefits over the normal process. So you need massive machine learning automation to be more productive, okay? Because everyone's talking about the data science shortage and the data scientist. What about making them more productive? And that's what MMLAs are about, making data scientists more productive. Now, finally, I want to talk about sort of an approach to getting back to the business priorities of user experience and customers. And certainly, customer experience isn't the only use case. There's lots of great use cases, industrial ones as well. But the customers want to be treated like celebrities. They want those individualized experiences, which is why social media is growing like this. They want to be out there. They want to be treated like celebrities. So think about what kind of customer experiences could you create faster if you had this technology. And people ask me, well, how do I find those opportunities? And you have to think like a venture capitalist, because we all in this room know that you can't just wish you had a predictive model. It's very experimental. So what does a venture capitalist do? They invest in 12 companies, knowing statistically that 2 or 3 of them will hit and they'll be fabulous successes. That's what you have to do in your business, looking for those opportunities. You need a dozen ideas to experiment, run those experiments, rapid iterations using MMLA, and it's pretty easy walk through a business process, whiteboard a business process and say, is there something I could predict here? Is there a perishable insight here? Is there some advanced analytic that could improve this process? You're going to come up with a dozen ideas pretty quickly. Same with the customer experience. Walk through that customer journey. Is there something here that I could predict about this customer that would make a better experience? And you'll quickly come up with that ideas. The problem is you have to teach your business that this is about experimentation, that you can't guarantee them a model and an ROI. You need an R&D budget, and it needs to be thought of as R&D. So my perspective is only the analytical enterprise. The enterprise that implements these 4 types of analytics can be truly a data-driven enterprise. And you just have to build those real-time predictive applications to make that happen. Thank you.